So integration by parts, a new method for integration. But before I tell you what integration by parts is, what I'm going to do is, first of all, just derive an identity, and all will become clear in a second why I'm doing that. So first of all, I'm going to take the product rule for differentiation. So taking the product rule for differentiation, uv differentiated, the differential of the product of two functions, equals v du by dx plus u dv by dx. So what I'm going to do is I'm simply going to take this term over to the other side, which implies uv dash minus v du by dx equals u dv by dx. Again, I don't expect you to have any idea why I'm doing this currently. That will become clear in a minute. So next thing I'm going to do, just write it with u dv by dx as the subject, so no rearrangement, just writing that term on the left hand side and that term on the right hand side. So I've taken the product rule and I've rearranged it to that form. What I'm now going to do is integrate both sides with respect to x. So integrate both sides with respect to x. So that means that the integral of u dv by dx equals the integral of uv differentiated dx minus the integral of v du by dx. So I've integrated both sides. Move that across there a bit. I've integrated both sides with respect to x. So now let's try and simplify that. So we get the integral, can't simplify this, that's as simple as it'll get, dv by dx equals, now this one here will simplify because I've differentiated something with respect to x, then integrated it again. So that just becomes uv, differentiated, integrated, just uv, minus the integral of v du by dx. And actually, now what I've derived here is a formula that says if I've got the integral of the product of two things, the first thing in the product being u and the second thing in the product being dv by dx, then actually an equivalent way of writing it, an equivalent answer can be gained by doing this alternative integral uv, take away the integral of v du by dx. So that's what this says. So I've taken a formula that I know to be true, rearranged it a bit, seemingly randomly so, and derived this other formula here, which again says the integral of the product of two things, the first thing in the product being u and the second thing being dv by dx, equals uv minus the integral of v du by dx. So this is the formula that you get in your formula booklet for integration by parts. So this here is the key formula. Don't need to learn it because it is given in the exam formula booklet, but it is a key formula to be able to use. So let's see it in use now. So let's say we've got e.g. we've got the integral of x e to the x dx. Now, truth be told, I've got no idea currently how to integrate that in its current form. It's too difficult just to look at and integrate. We don't know the answer to that. So what we're going to have to do is find a different way of writing it so that we'll have some form of hope of being able to integrate it. And that's where this integration by parts comes in, because it says the integral of the product of two things. Well, I've got the product of two things here. I've got x times e to the x. So in this case, our u equals x, and that means that if we differentiate that, du by dx equals 1. And our dv by dx, the second thing, equals e to the x, which means that v, if we integrate that to get v, equals e to the x. So we've got all the ingredients now to make this formula work, so I can write this integral in an equivalent way, which will make it possibly integrable, possibly not. We'll see writing it in the way the right-hand side, the form of the right-hand side, we'll see if that actually gives a more doable integral. So equals uv, so x e to the x, minus the integral of v e to the x du by dx times 1, so I'm not going to bother writing anything, dx. And that certainly is doable now. Equals x e to the x minus e to the x plus c. So we've got an answer, but there's nothing saying, currently, I don't expect you to believe me that that's the answer. I'm actually just going to check it now as a one-off to show you that that actually, when I differentiate it, gets us back to where we started. So d dx, the differential of x e to the x minus e to the x plus c, equals, so here we've got the product rule for differentiation, u, v. So we've got v u dash plus u v dash minus the integral, the differential of e to the x is e to the x, and the differential of c is 0, so plus 0. So what we've got here is that e to the x times 1 minus e to the x, yeah, they disappear, leaving just x e to the x, which is where we started. So if we integrate that, we do indeed get that. If we differentiate that, we get back to there. So that is how integration, how and why integration by parts works. It's a rearrangement of the product rule for differentiation. So let's try another example. E.g., the integral of x sine x dx, and I'll just put the formula here. So the integral of u dv by dx is the equivalent of uv minus the integral of v du by dx. So take a moment, let u equal the first thing, let dv by dx equals the second thing. So I almost said a terrible thing there, because the most common error is to let u equal x and let v equal sine x, but that's not the right thing to do at all, and I almost said that there. It's to let u equals x and let dv by dx equal the second thing. So take a moment, do that yourself. See what happens. So I always like to do the working at the side for this, so I don't break the flow of what I'm trying to do on the left hand side. So u equals x, which means that du by dx equals 1. dv by dx equals the second term, sine x, which means that v equals the integral of sine x, which is minus cos x. And just a small note, you might think to yourself, well, I'm integrating that, so why isn't there a plus c there? we do get a plus c. We just deal with it right at the end. We're putting off dealing with a plus c right until the last step. So now writing it in an equivalent form, that's equal to uv minus the integral of v du by dx. So we've got an equivalent form there. Equals, and I just want to tidy this up before I attempt the integration. Double minus makes a plus. The integral of cos x dx equals minus x cos x plus, and the integral of cos x is sin x plus c. And if you struggle with your integrals of trig functions, this is the wheel of differentiation for trig functions. This is how they differentiate. Sine goes to cos, goes to minus sine, goes to minus cos, and integration just goes the opposite way. So cos in this case goes to sine. Let's try another. So I'll put one on here from a worksheet. So see if you can have a think about how to deal with that one. Give you 30 seconds to think about it, maybe make a start, then I'll give you a few pointers. Okay, so before we're ready to use integration by parts, and I'll just put the formula on screen again before I go any further. So you might want to copy that down because we're going to be using this formula all through the lesson. So take a moment to copy that down. It saves me having to write it out each time. So I'll give you 10 seconds to do that. Then I'll get back onto the question. Right, so it's not the product of two things currently, so we need to write it as such. Equals the integral of x e to the minus 3x dx. So now we are ready to use integration by parts. It's the product of two functions. That's not a hard and fast rule. There are some exceptions, but once we've done all of integration, I'm thinking of doing a week's lesson on just when to use each method. So u equals x, which means that du by dx equals 1. dv by dx equals e to the minus 3x, which means that v equals, and the integral of that is itself. But remember, we must divide by the differential of the power, which means it's minus a third times itself. Like that. Chain rule for differentiation reversed. So now we're ready to do the answer. uv, a third, x, or rather minus a third, x e to the minus 3x, minus the integral of v du by dx which is 1, so I'm not going to write it out, dx. Equals minus a third x e to the minus 3x. And I'm going to tidy this up before I try and integrate it. Double minus makes a plus. A third e to the minus 3x dx. And now we are ready to do the integration. Equals minus a third x e to the minus 3x. And the integral of that is itself divided by minus 3. So minus 1/9 e to the minus 3x. I always remember the plus c. Did I remember the plus c the last time? Yes, I did. So 1 mark to be lost for not remembering the plus c. So let's try another. E.g. the integral of x log x dx. Have a go at that, see what happens. I'll give you a 30-second head start, then I'll start explaining. Right, so a bit of a head start for you there. So in this case, u equals x, so du by dx equals 1. dv by dx equals log x, which means that, we've ran into a problem here because we don't know how to integrate ln x. Common misconception is that the integral of ln x is 1 over x, but actually not true. It's the integral of 1 over x equals log x. So we don't know how to integrate yet log of x. So basically, what I've done, I've chosen the wrong letters for x and ln x. I let u equal x, which I shouldn't have done in this case. Now, there's not really any way of knowing which the right one is. You sort of get a feel as you get more experience with these types of question. But as a loose rule, or for the purposes of A-level maths, a hard and fast rule, just in wider mathematics it's a bit of a loose rule. If ever there's a ln x in an integral, integration by parts, then that should take priority for b and u. But basically what I've shown you there is that if you're unsure which one to let equal u and which one to let equal dv by dx, don't worry, just let one of them equal it, and just guess, and 20 seconds later, if you are wrong, you'll know about it because you can't get past this step here. So in this case, let u equal ln x, which means that du by dx equals 1 over x. We'll let dv by dx equal x squared, equals x. One step ahead there. Which means that v equals x squared over 2. So now let's see if that makes it simpler. So you've got the formula hopefully written down next to you. So equals uv x squared over 2 log x minus the integral of v du by dx dx. And actually that is looking doable. So x squared over 2 log x, tidied up before I attempt the integration to avoid the chance of any errors, minus the integral. So x over x is just x, 2 on the bottom, dx equals x squared over 2 log x minus x squared over 4 plus c. And if you were to differentiate that using the product rule for differentiation, you'd see it gets us back to where we started. So nice and straightforward. Let's try one now with limits. So let's take this one here. Because these ones with limits can be quite confusing purely because of the layout. The mathematics is no more difficult. It is the layout that's the problem. So get as far as integrating that by parts, but stop short of putting the limits in. And I'll just show you, I'll give you a chance to get there, but I'll just show you how the notation should work when we get to that point. So, as usual, 30-second to a minute head start, then I'll have a go. So, no ln's involved, so u should be the thing that we're going to make simpler or make disappear. U equals x, and it's made to disappear by differentiating it. dv by dx equals e to the minus x, which implies that v equals minus e to the minus x. Equals uv, so minus x e to the minus x, uv, minus the integral of v du by dx, which is 1 dx. Now the common error here in layout is to put the limits on the integral there, but we've actually done part of the integral already. We've done that bit, so if you put the limits just on there, it's not technically correct. So the best way to write it now is like that. Put the limits completely outside the full thing, and that covers you. Then the working is correct. Equals minus x e to the minus x plus, tidying this up before I attempt any integration, I don't want any errors to happen, between 2 and 0, equals minus x e to the minus x, and the integral of that is minus e to the minus x, between 2 and 0, and now we're ready to sub the limits in. But as always is the case in integration in general, when we've got limits, we need to show it being subbed into every term just to cover our backs, because if we don't, then we're risk losing marks for method. If we get a wrong answer, the act of subbing in the limits is actually worth a mark, provided you have the correct limits, that is. So that's what I'm going to do now. So minus 2 e to the minus 2 minus e to the minus 2, sub 2 in, 0 e to the 0 minus e to the 0. So there's a mark for that, even if my final answer is wrong. So that's 0 So here I get equals minus 3 e to the minus 2 in that first bracket. Double take 1. And so as not to be awkward, I want to give them back exactly what they asked for. 1 minus 3 e to the minus 2 is the answer that they were wanting. So that's how limits work. Let's try another bit more difficult one, this one. The integral of x squared e to the x. As usual, 30-second to a minute head start, and I'll start explaining it. Right, so in this case, we'll let u equal x squared, which means du by dx equals 2x. We're going to let dv by dx equals e to the x, which means that v is just the same, e to the x. Therefore, that's equal to uv minus the integral of v du by dx. So that's 2x e to the x. V times du by dx gives us 2x e to the x dx. And we're not yet ready to be able to do this. The integral of 2x e to the x isn't readily doable. We need to do something extra. And actually, the thing you've got to notice is that this is integration by parts. Again, we need to do another integration by parts. So what I like to do, just put a little set of braces under it and a little star, a little asterisk, to indicate that this bit of working here corresponds to this bit at the side. And I always like doing this bit at the side, and the reason for that is I don't want to break the flow of these chain of equal signs. I think the solution becomes a little bit sloppy if you do that. So in this case, let u equal 2x, which means that du by dx equals 2. Let dv by dx equal e to the x, which means that v also equals e to the x, like that. So now we're ready to put it into this. So equals x squared e to the x minus, and that integral becomes uv Remember, the minus sign applies to all of that. uv 2x e to the x minus the integral of v du by dx dx. Equals, let's tidy it up a little bit before I do any more. X squared e to the x, take 2x e to the x, double take the integral of 2e to the x dx plus c. So I'll leave the plus c for later because I haven't done the final integral yet. What I've written there wasn't wrong, but best leave it for the next step. Equals x squared e to the x, take 2x e to the x plus 2e to the x plus c. So some questions you're asked, you might be expected to do integration by parts twice, and that's probably the greatest level of difficulty that a question like this would get to. So what I want to do now is just go through a few exam style questions. So I think it's important to be able to put this into an exam context. So just getting ready a question now to put on there. And these are all from past papers. So let's try this one here that's about to appear on the screen. So I'll give you a bit of a longer head start on this one. I'll give you a couple of minutes, because really I want you to try and get on with this independently now. So a couple of minutes, then I'll go through it. Right, so my solution, and the key here was to remember that when there's a natural log involved, that should really take priority as being u. So u is log of 3x, which means that du by dx equals 1 over 3x, 1 over whatever's in the bracket, times the differential of the bracket, times 3, leaving just 1 over x. Just on a side note, it's difficult to imagine why log of 3x has the same gradient function as log of x. So log of x differentiates to 1 over x as well. So the reason for that, hopefully I can convince you of it this way, log of 3x, if we use the addition rule for logarithms, you'll see that it's log of 3 plus log of x. So by timesing by that 3 actually, we're doing a translation of the graph. We're moving it in the y direction 3 units. So actually, by just moving a graph upwards, by translating it upwards, the gradient at any particular x value stays the same. So that's why log of 3x has the same gradient as log of x. dv by dx equals x to the 8, which means that v equals x to the power of 9 over 9. Add 1 to the power, divide by the new power. So now we're ready to do integration by parts. Equals uv minus the integral of v du by dx dx. And let's tidy this up before we attempt to integrate it. Equals x to the 9 over 9 log of 3x minus x to the 8 over 9 integrated dx equals x to the 9 over 9 log of 3x minus, then add 1 to the power, divide by the new power, plus c. And there's the answer to that one. So here's a rather fiendish looking one here. Take a look at this. I'll give you a couple of minutes head start again. So this goes back to previous lessons, used division to show that that's the case there for part 1. Then for part 2, which somehow looks to link to part 1 but don't quite know how. Do the integration by parts. So actually I'll give you more than a couple of minutes. This is one that's probably going to take quite a bit of thought. I'll do part 1 in 2 minutes, then give you plenty of time to do the integration by parts to see how it relates to the to part 1 of the question. Sorry about the background noise there. There seems to be work going on outside. Right, so division, part 1. So t cubed divided by t plus 2. Now I prefer to use a grid for polynomial division. T plus 2 times something, whatever that is there, to equal t cubed. So in order to find out what that thing is, well, first of all, finding out what goes at the top of this column, it has to be t squared to make the positive t cubed, which has the unintended consequence, though, of leaving us with an extra 2t squareds, so plus 2t squared. Now we don't want that 2t squared, because the answer's just t cubed. We only want the answer t cubed. So take away 2t squared. That leaves us with no t squareds, which is what we want. And for that to happen, the top here, minus 2t has to go there. Finish off the column. So minus 2t times 2 makes minus 4t. We don't want minus 4t's. There's no t term in t cubed. So I'm going to add 4t's there. And to make that column work, it has to be a plus 4 at the top. T times 4 is 4t. Then we've got plus 8. But we don't want a plus 8, but we've ran out of space in the grid now. So that has to be the remainder. So to get rid of that plus 8 on the outside, minus 8. So what we've got now, we've got the quotient and we've got the remainder. And let's just spell that out. Quotient, remainder. Therefore, t cubed over t plus 2 is the quotient. T squared minus 2t plus 4. Take away the remainder, minus 8 over t plus 2. So take away the remainder over what we're asked to divide by. If you're unsure about polynomial division, go back to the lesson that I did on it. I think it was one of the first lessons I did, and all the resources there. Watch the video, do the exercises. So I'm going to give you a moment to do that bit now. So we've proved this here. That has to be useful in part 2, otherwise they wouldn't have asked us to do it. So take a moment. Right, so in this case, I'll just bring the question down here a bit actually to remind ourselves. Just going to go off screen in just a second. So So just remember what we proved. I'll leave that at the top of the screen. So this looks like an integration by parts, the product of two functions. And again, product of two functions isn't a hard and fast rule. It could also be a substitution, but we'll go through again at a later date when and where to use each method when you're not told which method to use. So U always takes priority as being the log, remember, for the purposes of A-level maths. One over t plus 2 times the differential of what's in the bracket, which is 1. So they've tried to catch us out by writing it in a different order. Your gut reaction would be to let U equal the first thing and dv by dx equal the second thing. Not always the case, as this question and a couple of previous ones we've done have illustrated. So dv by dx now equals 6t squared, which means that v equals 6t cubed over 3, so 2t cubed. So now it becomes uv log of t plus 2 times 2t cubed. So I'll write that in a nice order. Don't know why that's the case, if it's just habit, but it does look a lot nicer if I write it like that rather than log of t plus 2, 2t cubed. uv minus the integral of v du by dx times 1 over t plus 2 dx. And now it's a bit more apparent. We've almost got what we proved in the first part, except this one, there's two of them. And remember, there are limits, so I'm going to put those in there as well, 2 and 1. So I'm going to give you a moment again, if you haven't got this far, to take over. Hard question, so I think it's really worth you persevering on that and getting the satisfaction of having done it yourself. Right, so equals, let's finish the integration, 2t cubed log of t plus 2 minus, and this 2 I think is better thought of at the front. Then we can use the identity we've proved here directly. 2 lots of And we're not going to integrate yet, but we know that 2t cubed over t plus 2 is the equivalent of t squared minus 2t plus 4 minus 8 over t plus 2 dt. So I've taken t cubed over t plus 2 and converted it into this equivalent form, which we proved in part A. Close brackets, between 2 and 1. So quite a difficult question. There's a reason it's worth 6 marks. So it should take 8 to 10 minutes to do these 6 marks. Two t cubed log of t plus 2 minus 2 lots of, and we're ready to integrate this now. So the integral of t squared t cubed over 3 minus 2t squared over 2 minus t squared plus 4t minus an 8 over t plus 2 becomes 8 log of t plus 2. Between 2 and 1. Let's keep going. So I want to, before I do any more, multiply these brackets out just to make it nice and in line, because the answer has to be in this form, no brackets in it. Equals 2t cubed log of t plus 2 minus 2t cubed over 3 double minus 2t squared minus 8t double minus 16 log of t plus 2 between 2 and 1. I'll scroll up a bit, and again I'll give you a moment to get that done, but there's the form it wants the answer in. I'll put that to the side just so you remember. Get subbing in, take great care and see if you can get it in that form there. Equals, and as I said, as good practice, let's just put the numbers in for now. 2 lots of 2 cubed, make that look more like a 3, log of 2 plus 2, which is 4, take away 2 lots of 2 cubed over 3 plus 2 lots of 2 squared minus 8 lots of 2 plus 16 log of 2 plus 2, which is 4, minus 2 lots 1 cubed. I think we can be forgiven for not writing. No, actually, let's write it. Let's get the mark in case our final answer is wrong. ln of 3, take away 2 lots of 1 cubed over 3, plus 2 lots of 1 squared, minus 8 lot of 1, plus 16 log 3. Right, let's tidy this up now. Equals. So anything with an ln, don't put it in your calculator, otherwise it'll give you a long decimal. We need an exact answer in that form, and if you put ln's in your calculator, it's only going to give you a rounded answer, since ln's are irrational apart from log 1 or log of an e. So that becomes, so 2 times 2 cubed, 8 times 2 is 16 log 4, take away, and let's just do the number part on our calculator. So we know that it's fair game to put this bit in our calculator here. It is just going to give us a number. So 2 lots, or rather almost fell into a trap there, negative 2 lots of 2 cubed over 3 plus 2 lots of 2 squared. Some of this I should be able to do in my head, but I'm not going to, simply because it's just easier not to. Minus 8 lots of 2, which is minus 40 over 3. Minus 40 over 3. Plus 16 log 4. Take. So 2 times 1 cubed log 3 is just 2 log 3. And putting the rest of it in the calculator, we get 2 lots of minus 2 over 3 plus 2 lots of 1 squared minus 8 gives us minus 20 over 3 plus 16 log 3. I forgot to close the bracket up there. Okay, almost there. So that gives me 32 log 4 minus 40 over 3, double minus 20 over 3. So minus 40 over 3 plus 20 over 3 leaves us minus 20 over 3. Then the log 3's. So 2 log 3 plus 16 log 3 is 18 log 3, and there's a minus at the front. Minus 18 log 3. And that's it done. So we'll finish there. Integration by parts. Practice the worksheet.